Let's do a lab problem from section 11.10. This is problem number 2. They want us to find a Taylor series centered at the given value of A. Assume that we have a series expansion and we don't have to show that the remainder goes to 0. And then they want us to find the associated radius of convergence. So the Taylor series formula looks like this: f of a plus f prime of a evaluated at a, and then x minus a, and then f double prime of a divided by 2 factorial times x minus a squared, etc. And so it looks like we're going to need a bunch of derivatives, and they're saying that if we take the 5 out, we can take a look at what happens to this when we take the derivative of 1 over x. So just as something on the side here, a sketch pad. So the derivative of 1 over x is like looking at negative 1, or x to the negative 1, so that's a minus 1 times x, and then we have to subtract 1, that's negative 2. And so we can rewrite that as negative 1 divided by x squared. And so I think that's what they want us to write here, negative 1, and then the power is 2. Now if we want to find the second derivative, let's throw another prime in here. Second derivative. And so this is going to be negative times a negative, so that's a positive 2. And then we subtract 1, so that's going to be 3. And this would be a 2 positive to the third power. So this is a positive 2, and then in the denominator it's a third power. So you can see the pattern for the denominator. The power in the denominator is going to continue to go up, and the power in the numerator is actually going to get multiplied by a negative of the previous power. So this is going to be negative 3 times positive 2. That's going to give us a negative 6. And then it's going to be negative 4 times positive or negative 6. That's going to be a positive, and then that's 6 times 4 is 24. Now if you were really like paying attention to this and catching this, these numbers 1, 2, 6, and 24 are all factorials. So we can examine that a little bit later. Now with a is equal to negative 3, we want to put negative 3 in for x. So when we put negative 3 in for x, what are we going to get here? So in our original function, the 5 is out here, and x is going to be negative 3. And so this is going to give us a negative 1. For the first derivative, we have x squared, so this is going to be x is negative 3 squared, so the negative becomes a positive. And then in our first derivative, we also get a negative 1. So let's put in a negative 1. And then now for the double prime, there's a 2 in the numerator. This is negative 3 that goes into the denominator, but it's to the third power, so that should be a negative. And then so let's just put negative 2. And then after that, negative 3 to the fourth power is going to be positive 3 to the fourth. And then we have a 6 over there, but we have a negative 6 up on top. So that's going to give us a negative 6. And 5, this is going to be a negative 3 to the fifth power, which will give us a negative number. And then the numerator is 24, so this is going to give us a negative 24. So, like I had mentioned, we have the first one is 5 over negative 3. That's the original function right here. This is 5 over 3 with a negative, so that's negative 5/3. That's a constant term. And now let's take a look at the linear term. So the linear term is just f prime of a. So the linear term is f prime of a, and so here we get 5, that's negative over 3 squared. So let's write 5 divided by 3 squared. The next one is going to be the double prime divided by 2. So the double prime is here. This is 5, and we're multiplying it by negative 2, and we're dividing it by negative or by positive 2. So that's going to give us a negative number. Oh, I think this should have been a negative also. This is going to give us a negative number, and then the 2 and the 2 from the factorial will cancel, and then I just have a 5 to the 3, 5 divided by 3 to the 3rd power. If we go to the next term, this is the cubic term. I have f triple prime evaluated at a divided by 3 factorial. So the triple prime evaluated at negative 3 is going to be 5 times negative 6 divided by 3 to the 4th. Now 3 factorial in our formula is equal to 6, and we have a negative, so let's throw in a negative 5, and then we're dividing by 3 to the 4th. And so what we're hoping, or what I'm hoping, is that you're seeing a pattern here. You got 5 divided by 3, negative, they're all negatives. We have 5 divided by 3, but divided by 3 squared, 5 divided by 3 to the 3rd, etc. So this is probably going to be, let's try that again. So it's negative 5 divided by 3 to the 1 more power up is to the 5th power. Okay, so now we can see that pattern. It looks like we have 5 is a constant, and there's a negative 5 outside, and then we have 3 that's being raised to a power, and it has to start with n is equal to 0. So we have a 3 in the denominator already, so if we put a plus 1 there, that would go up 1. And then we have an x minus 3, or x plus 3, being raised to the nth power. And that should be our power series, our Taylor polynomial. Okay, now to find the radius of convergence, we're going to run it through the ratio test. Wherever we see an n, we're going to add 1. Let's see what we have here. We have a negative 5, 3 to the n plus 1, x. So this should be n plus 1. And then we have 3. They may have written this backwards. I think this should be a 3 to the n, because it's a 3 to the n in the denominator. So I believe if this is correct, then they may have made a mistake. Let's submit it. All right. So they did the reciprocal, so this should be n plus 1 plus 1, so that's n plus 2. Gets kind of tricky when you're not doing it on your own here. You're following their steps. All right, so now we simplify this. It looks like negative 5 cancels. it looks like a bunch of these would cancel. That would leave a 3 in the denominator. We have this cancels. N of them would cancel, and then that would leave an x plus 3 in the numerator. And then we have an n plus 1. That's it. So if we take the limit here, this is going to be equal to 3. Or there's no more n's here, so it's actually going to be equal to this. So let's do the absolute value of x plus 3. And then divided by 3. And then now, since this is your limit, we're solving for the x plus 3 here, so we're going to multiply by 3 on both sides, so the radius of convergence is going to be 3. Okay, so it looks like this problem is done. Let's go back and take a look at the actual function. This is 5 over x, and at a equals -3. So again, Desmos has a program set up. I put in my function, and my radius or my center point is -3. So I'm here. Notice that this has a discontinuity at x equals 0, and that is a distance of 3 units away from the center point. So that's going to dictate my radius of convergence there, where my graph breaks. On the left side, it's going to break it the same way on the right side with the Taylor polynomials. So this is my tangent line. This is my tangent parabola, cubic function, the 4th degree function, and the 5th function. You see that it breaks off over here. It goes to -5. With a high enough Taylor series, I would get a little bit closer here to 3 units away from -3 on the left, so that's -6, but I'm not going to go past that. I'm not going to be able to approximate a larger value on the negative side, like -10 or -8 or anything like that. Okay? All right, I hope that helps.